Good morning, guys, to all of you. I welcome you all for this wonderful session. So, guys, as you know, Rank Up series is going on in which we are discussing some wonderful question to make your rank on the upper side, means on the better side. So, guys, today's session is related to the machine design subject, and generally it is a subject which is coming in the difficult subjects for the students. But I would say it is the scoring one because the question which are asked from this are very easy to do, and I will recommend you not to leave this. And because the way they are asking the question, the things are very simple and very easily you can score, because the type of questions are almost fixed type. Okay, so there is not much twist happening in these questions, so that is why always we must do this subject. If you talk about the weightage, yes, previous year weightage was lesser, otherwise the weightage is going for 4 to 5 marks, which is a decent one. Okay, so guys, we are going to start. We are having the question from all the areas in this session. Question from brake is there, question from bearing is there, question from joints are there. Okay, fatigue loading is there, theory of failure is there. So we are starting, guys. So the subject today is machine design. Moving further, if you want to get the PDF of this session, handwritten notes of various subjects, then you can join my Telegram channel, that is Mechanical by Dheeraj Sardana. And guys, this is the Rank Up series, you can say schedule for civil and mechanical branch. So today we are having the machine design actually. Okay, so after that you can see the other topics, okay, are going to be like that. Theory of machine session I will be taking maybe on Saturday or whenever we will get the time. So guys, this is the very first question we are going to do. This is from theories of failure. So let me share the session. This is the very first question from theories of failure. Very first question from theories of failure. Yes, Vivek, Jai Hind bhai, kaise ho aap? So this is the very first question from theories of failure, guys. So don't worry, I will give you hint to solve. Okay, and this question is saying that a component is subjected to biaxial state of stress sigma xx 400 MPa, sigma yy is 0, tau xy is 200 MPa if yield strength in tension is 500 MPa and ultimate strength in tension is 500 MPa. The factor of safety as per the distortion energy theory. So my dear, first of all we will be finding out the principal stresses. You know the formula for principal stresses is sigma xx plus sigma yy by 2. And then you will be having plus minus square root of sigma xx minus sigma yy by 2 ka square plus tau xy ka whole square. And my dear, you will be finding out the value of principal stresses from here. And once you will be getting the principal stresses, then you know what is distortion energy theory. It is saying sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equals to SYT square upon N square. So my dear, this is the expression for maximum distortion energy theory. From here you can find out the factor of safety. Okay, that is they have asked. So yes, can you try and tell me the answer? Yes, Vivek. Solve it, guys. Solve it, solve it. Solve this question, guys. Okay. So when we will be solving this, you will be getting the factor of safety to be 0.96. So D would be the answer for this. Okay. Are you getting it? How to do this type of question? So the answer will be D for this. And 0.96 you will be getting. So you may be thinking, sir, how factor of safety can be less than 1? If factor of safety is coming less than 1, it means failure is sure. It means failure will definitely happen. Okay, that is the meaning of this. So moving to the next question, guys. This is once again from the theories of failure. Theories of failure is the most important topic of this machine design subject. So you can see the question, the homogeneous state of stress for a metal part undergoing plastic deformation is given by. So you are given this state of stress And they are saying that distortion energy per unit volume for metal part having Poisson ratio 0.3 and Young's modulus 200 GPa is. So guys, finally you need to find out distortion energy per unit volume. So if you remember, the formula for distortion energy per unit volume is 1 plus mu by 3e, and that is going to be sigma 1 ka square plus sigma 2 ka square plus sigma 3 ka square minus sigma 1 sigma 2 minus sigma 2 sigma 3 minus sigma 1 sigma 3. That is going to be the distortion energy per unit volume. I would like to say this question is very, very easy actually. It could be difficult if he make these terms also non-zero. Because if these terms are non-zero, then it will be having three principal stresses, and you would be having the one way to find out the principal stresses in the way of eigenvalues of this matrix. Okay. But right now, my dear, as they have already given those values 0, what do you mean by that? Because of this, at these values are 0. So you can say that in the z direction we have shear 0. So this would be acting like the sigma 3. So z direction will be the principal plane. So sigma 3 we already know as minus 10. For this 2 by 2 matrix we can find out sigma 1 and sigma 2. Because you know in the 2 by 2 matrix it is sigma xx, it is tau xy, it is tau yx, it is sigma yy. So my dear, we can definitely find out sigma 1 comma 2 as sigma xx plus sigma yy by 2 ka plus minus square root of xx minus yy by 2 ka square plus tau xy ka whole square. Is it clear, guys? So if we are having this, you will be getting the value of sigma 1 and 2 like that. Now you already have sigma 1, sigma 2, sigma 3. You will put all the values into this and you will get the distortion energy per unit volume in joule per meter cube. This is the numerical answer type question, and when you will be solving this, you would be getting the answer to be 1679.06 joule per meter cube. So this would be the answer for this question, guys. This was question number 2. Now we are moving to the next question. This is the third question. This is from fatigue loading, guys. Okay, now we have two questions from fatigue loading. One is from ascent diagram, other is from, you can say, from the other parts like endurance limit and all. So this question is saying, a rotating beam test specimen when loaded to a stress of 900 MPa gives a life of 1000 load cycle. What do you mean by that? You already know we are going to start it by log base 10. Then you will be having 0.9 SUT. Related to this, we are having 1000 cycles. So 1000 cycles we are denoted it by 3 because here we are having log base 10 N. So obviously here 4, here 5, here 6. So you would be having here 6. When loaded 500 MPa, it will give 10 power 6. So guys, can you feel it? This will be the endurance limit, log base 10 SC. So the curve will be coming like this. Okay. So they have already given you that SC is equals to 500 and 0.9 SUT is 900. These are given to you. And look at the question. They are saying if the required life of the component is 50,000 cycles. So they have given some life actually. They have given some life that is 50,000 cycles. Let us say it is coming somewhere here. So you need to find out the stress for that. Let us assume log base 10 sigma. Now you need to play with the triangles. You can see one triangle is this small one. Other triangle is the bigger one. So you just need to make the similarity of triangle. This angle is equal because same line. This angle is 90. So obviously third angle is common. So by angle similarity, we can say that they are going to be equal. Now if we want to write down, like you can say log base 10 900 minus log base 10 sigma, this divided by that. The number of cycle is log base 10 50,000 minus 3. That will be equals to log base 10. 900 minus log base 10. Endurance limit is 500. Divided by 6 minus 3. This will give you the value of sigma. And when you will be solving, yes, Vipin Mishra, good morning, dear. Papa Ka Ghoda, good morning. So you would be getting the answer from this. The sigma will be, you would be getting it to be 645 MPa. So answer will be A for this. Okay, so you guys are late today. Please try to join on the time. Okay. Yes, Manikanta, very good. So this is option A is correct. So we are moving to the next question, that is question number 4. Okay, this is once again from the fatigue loading. Now I want answer from all of your side. Yes, Papa Ka Ghoda, you are correct for the previous question. Answer was A only. Now try to solve this question. Try to solve this question. This question is a steel component has the following data, where they are saying the ultimate strength is 600 MPa. Yield strength is 400 MPa. Then you can see the surface finish factor is 0.8. Size factor is 0.75. Reliability factor is 0.8. Fatigue stress concentration factor is 1.6. The endurance strength of the component. So I would like to give you a hint that first of all, you need to find out the corrected endurance strength, which is given as Ka, Kb, Kc, Kd into endurance strength. And what is the endurance strength of RR More experiment? It is 0.5 times of ultimate strength. So first you need to find out SC, then you need to find out SC star. I feel all the factors are given. This 1.6 is Kf. What is Kd? 1 by Kf. So I feel that much hint is okay to solve this question. Yes. So Vipin, Vivek, Manikanta, Papa Ka Ghoda, everyone. This is question number 4. We have 12 questions today. Okay. So 8 more questions after this. We have question from brake, question from that joint, question from bearing. Okay. All the topics are covered. We have already seen 2 questions on theories of failure. Now 2 questions on fatigue loadings are going on. Okay. Manikanta is saying the answer to be 90 MPa. And I feel the answer is correct. Because you will say SC is 0.5 SUT for steel. What is SUT? SUT 600. So this will be 300. Now you will say the corrected endurance strength. Ka, surface finish factor is 0.8. This is 0.75. 0.8. 1 by 1.6 into 300. The answer will be 90 MPa. Yes, Vipin. Yes, aspirant. So 90 MPa is the correct answer. Moving to question number 5, guys. This is from the Minor's rule. This question is from the Minor's rule. You know cumulative fatigue failure? This question is from cumulative fatigue failure. So you know that the life of the machine component under heavy test load is 10 hours. So heavy test load is sigma 1, under which the life is 10 hours. The life under combined loading was 18 hours. So total life is 18 hours. Out of which 9.8 hours was at the heavy load. Okay. So this is 9.8 hours. I feel everybody know this is N1, this is small n1. And 8.2 hours was on the normal load. Normal load is sigma 2. And this is N2, not given to us. 8.2 hours. The expected life under normal operating load. This you need to calculate. I feel everybody would be remembering the equation. Sigma 1 by N1, sigma 2 by N2, 1 by N. Is it like that? Is it like that? Or I have written something wrong? Sorry. This is not sigma 1, this is small n1. This will be small n1, small n2. Yes, now it is correct. Can you solve it? Small n1 is 9.8 here, 8.2 here. This is n1, this is n2. Capital N1 is known, capital N2 is not known. Solve it and get the answer. We can write 9.8 by 10. 8.2 by N2. What you are getting, guys? Actually, this is misprint. It is 410 hours. It is 410 hours. That's correct. That correct. Answer will be 410 hours. Because in I have solved also, the answer is 410. That is misprint. Fine. D is correct answer. 410 hours. So we have covered nearly all the topic. Minor's rule is also covered. Now moving to the next question. So as you know, this series is going on, started from 5th of October and will continue like that only. So next is question number 6 from Riveted joint. This is easy question, 1 mark question. Because this question is favorite for GATE people. Efficiency. Efficiency of Riveted joint. I feel everybody would be aware. It is given as P minus D by P. P is pitch, D is diameter of hole. Try to solve this question, guys. Try to solve this question. In a riveted joint, the diameter of rivet hole is 20 mm. Pitch of that is 3.5 times. So P is 3.5 D. Okay, if you want in the percentage, multiplied by 100. Solve it and get the answer. It is very easy, na? Answer will be near to 70%. Actually, it will be 71.43%. So 70% is correct. C is correct, na? How D? If you are getting 71.43, it is near to 70. Moving to the next question. Next is also on the same formula. Here they have given the efficiency. So efficiency is P minus D by P. You need to find out the pitch. Very good, Manikanta. Tell me the answer for this one. Tell me the answer for this one. So guys, how many of you want the series on BEL exam? Please tell me that. You know BEL is there in December. Large number of posts. More than 60 posts for mechanical, for probationary engineer. If you want on that series, we will be coming up soon. Okay, Vipin is saying the answer to be B. What about others? What about others? 100. Yes, very good. Everyone is correct. So guys, if you guys are not added to my mathematics group, you can tell me on the Telegram so that I can add you, because there I share the material related to mathematics. Like yesterday also I shared a handwritten notes file of mathematics. Yes. So if any of you is not added to my mathematics group, you can tell me on WhatsApp. I will add you there. Question number 8, guys. Because in the upcoming times, I am going to share a lot material there. Question number 8. This is eccentric loading, guys. The favorite topic of GATE. Great aspirant and Manikanta. For the reverted joint B, the resulting shear load on heavily loaded rivet is. Please tell me, guys. Please tell me. So guys, this is 10 kilonewton load acting at 75 mm. You know the procedure. First of all, you will be finding out the centroid. After finding out centroid, you will apply one load downward, one load upward, where this and this will make a couple. So for this rivet, if you see the loads, one is load, other is couple like this. So if you want to see the effect on the rivets, this will be the primary force, FP1, FP2. And as the couple is like this, this will be the secondary force 1. This will be the secondary force 2. And I feel everybody know that the primary force 1 is equals to primary force 2 is equals to total by 2. This is 10 kilonewton, so 10 by 2, because the number of rivets are 2. 5 kilonewton. To find out the secondary force, it is P into E into R2 divided by R1 square plus R2 square. I feel you can use the direct formula now. And you know what is R? Total is 50 mm. So from centroid, it is 25 and 25. So you can put the value and you can get the value of secondary force as well. Okay. And once you get primary, secondary force, what is resultant? Both are at 90 degree. This will be the answer. Yes, yes, yes. Tell me, guys. kilonewton is correct. Because primary is 5, I feel secondary will be coming out to be 15 kilonewton. So when you will be finding out the resultant, it is going to be 15 ka square plus 5 ka square. Overall, it is 15.81 kilonewton. So guys, you must have that kind of practice that these type of question you can solve very fastly like that. Okay, then it is going to be wonderful for you guys. Okay, moving further to the next question. Before that, I would like to tell about the workshop. Okay, sorry. Moving further to the next question. This is from the bearing part. The following data is given. Hydrodynamic bearing. Okay. Mu is 20 MPa. Density is 861. Journal speed is, radial load is, radius of journal is, radial clearance is, length of bearing is. Okay. So you need to find out the Sommerfeld number. So this is viscosity. Zn by P R by C1 ka square. So try to find out the Sommerfeld number. Yes, very good, Vipin. Try to find out the Sommerfeld number. Try to find out the Sommerfeld number. Sommerfeld number. Viscosity is given. This is viscosity. This is speed. For P, you can find out W by LD. Load is 2.5 kilonewton. Length is 40 mm. Diameter is also 40 mm. Because radius is 20. This will give you the P value. Rest is given to you. put the values and get the answer for the Sommerfeld number. Data is here, so I have written question here. Otherwise, question is there on the next slide. Put the value, get the answer. You have seen that at least 4 to 5 times Sommerfeld number is asked in the paper. So that is why it is important thing. This is question number 9. We have total 12 questions. So 3 more questions are in the row. Tell me the answer, guys. Tell me the answer. बोलो भाई. Sommerfeld number 20. Okay, this is, I feel, 20 millipascal. It should be, not mega. It should be milli. Let me check it. Is it milli na? Because it should be milli. Yes, it is milli only. It is milli only. So 20 into 10 to the power minus 3. Z, what is N30? Pressure will be, this is 2500 by 1600. Okay. So 2500 by 1600. It is Newton per mm square. So it is MPa. So then R by C1. R is 20. Radial clearance is nobody have done till now. Please tell me, guys. You know, it should be, pressure should be in Pascal. So I have done 10 to the power 6. So you need to find out the Sommerfeld number. These are the options available. 0.25, 0.15, 0.30 or 0.45. Yes, Bhavya, good afternoon. You won't believe that yesterday I was thinking to talk to you. I didn't talk to Bhavya for so many time. I was just thinking ki I will connect with you. Aspirant is saying B is the answer. And guys, the answer is correct. So if possible, Bhavya, please try to connect after this session. Okay, B is the correct answer. Moving to the next question. Okay, this is the next question. From the ball bearing. A ball bearing is subjected to a radial load of 5 kilonewton, is expected to have a life of 8000 hours, 1450 RPM, with a reliability of 99%. L99 you can find out 8000 into what is the revolution by 10 ki power 6. This will be million revolution. You need to find out the reliability with 90 in million revolution. I feel everybody understood what is required here. Yes. So when you will be using L99 by L90 is 1 by ln1 by reliability of 99, ln1 by reliability of 90 to the power 1 by 1.17. So you will get L90 in the million of revolutions. Try to find out this. Okay, 6.9 you are saying the answer to be. Let me check. No, 6.9 is not correct. First of all, you tell me what is this? This 10 power 6, 304050. Here you will left with only 10. So, 2 4 ja, 2 5 ja, 5 2 ja, 5 9 ja. So you will be having 29 into 4 into 6. If 99 is this one, 90 will be more than that, obviously. Tell me. Tell me, guys. Okay, 696. No aspirant. I feel some mistake you guys are doing. So it is ln 1 by 0.99. ln 1 by 0.9. 1 by 1.17. You need to find out L90. Arey bhaiya, L90 will be more than L99. So if I use the calculator for you guys, and if I try to tell you this 29 into 6 into 4, I feel this is 696, na? So if this is 696, L90 will be more than that, na? L99 is lesser, L90 will be more. Yes, you are correct, aspirant. For L99, 696 is correct. In the question, they are asking what is L90. So L90 will be obviously more than L99. Yes, that is correct, Vipin. The answer is 5185.96. 5185.96 is correct. That is surely correct. Moving to the 12th question, once again from the ball bearing. Yes, aspirant. So this is once again that kind of question where you need to find out the equivalent load. XVFR plus YFA into S. This will give you the equivalent load. Good afternoon, Aman. How are you? Then C upon PE is equals to L90. This is the case. You need to find out C. We need to find out C. Formulas are in front of you. I expect everyone will be doing. So guys, do like and share the session. This is rank up for machine design going on. Solve it. After this, we have one question from break. Last question. This is second last question. After this, we have one more question from breaks. So we would be having one more practice session of Tom, as because of some issues that session was cancelled. Tell me the answer for this. You can see radial load is 10 kilonewton, axial load is 4 kilonewton. 5000 hours is the desired inner race rotation. Service factor 1.5. X is 0.48, Y is 1.3. Race rotation factor is 1. Dynamic load carrying capacities. Solve this. First of all, find out PE. Are you getting 15 kilonewton? Are you getting 15 kilonewton? C will be PE L91 by 3. 15. L90 is 5000 hours. 5000 into 60 into 1200. Divide by 10 की power 6. Yes, Aman, which should I check? Equivalent ready or previous question, are you saying that is correct only? Previous question is correct only, Aman. If you're talking about these values, we can put it 0.48. V is 1, radial load is 10 kilonewton plus Y is 1.3 into what is axial load is 4 kilonewton. Service factor is 1.5. Is it not coming 15 kilonewton? Equivalent load is not coming 15 kilonewton. Please tell me that. Let me check otherwise. It will be 0.48 into 1 into 10. Okay. 4.8 plus 1.3 into 4 into 1.5. It is correct only 15 is coming. Okay. Yes, that is correct. 106.7 kilonewton is correct. D is correct answer. Wonderful, guys. Now we are moving to the last question from brakes. From shoe brake it is. And with this we will be completing the session of this machine design part. Last question, guys. So this question is saying for the block brake shown in the figure, the braking torque is, आपसे पूछा है braking torque कितना रहेगा? If the coefficient of friction is 0.35, the drum rotates in clockwise direction. So drum is rotating like this. So you know, for the drum, as it is rotating like this will be normal reaction, this will be the friction force, N, and this is mu N. So you know, on the shoe, mu N and N will have this direction. Okay. So you can see you need to find out mu N R. Braking torque is mu N R. So you will say summation moment about O to be 0. This is O. So 1 into 60 is equals to N into 20. From here you will get the value of N. Okay, once you will get N, put it here, get the answer. Very simple question. अब है, you are giving value for what? 0.2 is the value. Okay. For the answer, 0.2 is correct. Very good, Abhay. Very good. 0.2 is correct. So guys, those who want PDF of this session, I already told you on my Telegram channel, Mechanical by Dheeraj Sardana, you will get the PDF of all the session notification, all the notification PDFs, all the information related to any series if it is going on here on the app or any workshop which is coming. So all the information, handwritten notes, previous year's question, all these things are available on my Telegram channel, that is Mechanical by Dheeraj Sardana. So here I will say goodbye to you for this session and we will meet again soon. Okay. So as I already told you, we are going to start XCPYQs also. So be ready for that. So most probably on Saturday we will be starting this XCPYQs. Okay. So goodbye for this particular session. Goodbye.